A very good afternoon to everyone. So I'm here to present our work on Gehna, which was completed by me along with my co-authors Kartik and Aryan under the guidance of Dr. Aman Parnami at the Weave Lab in IIIT Delhi. So Gehna in Hindi means jewelry, and this paper is an exploration of designing touch and manipulation interactions with Gehna. So how do we do that? So there is inherent diversity in the physical form and the structure of jewelry. It can go from a simple gold ring, which is essentially just a metal band around your finger, to the extremely intricate and meticulously crafted jewelry worn by Rani Padmavat, who was the legendary queen of the kingdom of Mewar in ancient India. And similarly, there is a huge diversity in body placement. Jewelry as an adornment is used to adorn all body locations from the head to the toe. So we keep these two essential features offered by the jewelry, or these qualities of jewelry, as central to our analysis. We design the interactions based on the physical affordances of jewels and their on-body placement, i.e. how and where they are worn on the body. So now coming to the why of it. Why does it make sense to design interactions with jewels? So in 1991, Mark Weiser gave his vision of ubiquitous computing. He envisioned that the computer of the future won't be limited to its then popular forms of cell phone or a PC, and would merge with the objects around us or even our bodies. So since then, researchers in wearable computing and ubiquitous computing have developed many computers that we wear, like the Google Glass, or that are around us and we hardly notice them, like the smart homes. Now the question becomes, how do we communicate with these computers? Because it won't be necessary to carry these phones and use them to communicate with the computers. So to do that, researchers have, one way researchers have done that is by using the body as a medium of input. So the human body provides a large, easily accessible, and always available space for input, which can be used to communicate with the computers. So researchers have used our skin, our ears, our cheeks, the clothing that we wear, and even our nails to help us communicate with these computers. And normally these systems include a set of gestures which can be understood by the computer, and then the computer performs the required functionality. And broadly, these systems are either based on touch input or on physical manipulation input, which, for example, you manipulate your skin or your clothing. So jewelry is not only worn on the body, it's in fact the most versatile wearable. It's fashionable and ubiquitous. It's worn by people all over the world. Hence, we aim to design touch and manipulation interactions with jewelry. So this brings us to the concept of digital jewelry. This idea of adding technology or functionality to jewelry became popular in the late 1990s due to the efforts made by companies like IBM and IDEO, who wanted to create more socially acceptable wearables. For example, IBM created a jewelry smartphone or a jewelry cell phone which had a microphone embedded in the nose ring and a speaker embedded in the earring. And IDEO did some similar explorations. At the same time, the efforts made by designers who had a jewelry background became popular. And they instead focused on the cultural or social aspects associated with jewelry. For example, Nicole Stober developed the two rings which were worn by lovers. And when they touched hand, the rings glowed. So for this paper, we consider jewelry as a medium of input in sync with the motivations of ubiquitous computing as defined by Mark Weiser. We still think that discussing the efforts of jewelers or mentioning their efforts over here is important. So our focus is on everyday worn jewelry, and not on artifacts that have a social or cultural significance. So digital jewelry, the popularity of digital jewelry has increased considerably in the last few years, as concluded by Selena et al., who conducted a survey of this field. Usually modeled as a ring or a bracelet, these devices are used for many applications like health monitoring, sleep monitoring, or just motion tracking, and even notifications in some cases. So overall, this work is a parallel evolution this work is a novel outcome of this parallel evolution between digital jewelry and ubiquitous computing. So now we come to our research methodology. So we argue that the knowledge required to design input interaction with jewelry is segregated in 4 different disciplines. jewelry design and making, interaction design, system engineering, and input modality research. And we as interaction designers adopt the research through design procedure popularized by Zimmerman et al. To combine or synthesize the knowledge in these 4 disciplines to solve this problem. We started by collecting and analyzing a sample set of jewelry artifacts, and then based on this analysis and by reviewing the literature on jewelry design and making, we developed a taxonomy of jewelry design, which talks about how different parts of jewelry enable specific interactions. Finally, based on this taxonomy, we defined the interactions for our sample set of artifacts. Now we will look into each aspects of this process in more detail. So to collect our sample set of artifacts, we visited Dariba Kalan, which is one of the oldest jewelry market in Old Delhi part of India. In the past, it has been popular for traditional silver jewelry and crafts artifacts. But in the modern era now, it has become the hub of all kinds of jewelry. When visiting this place, we found jewelry for all body parts and a great variety of styles. So initially, we picked up artifacts that looked interesting to the eye and covered most body parts. But as we moved forward into our research procedure, we visited this market again several times to buy artifacts that exemplified other features that we discovered. So our final set consists of 30 artifacts and something for all the body parts, or most of the body parts. Apart from buying jewelry, we also spend time looking at the practices of local artisans and shopkeepers to gain knowledge about jewelry design and making procedures. So after this, by looking into the literature of jewelry design and making and this hands-on experience with jewelry, we defined a taxonomy of jewelry design. And here it is important to consider that our taxonomy is admittedly biased towards jewelry that enable novel interactions, because that was the purpose of this paper. So now coming to the taxonomy itself, the first important part of the taxonomy is Jewelements, which are the basic jewelry elements that can be found in most jewelry over the world. So this slide shows some of the Jewelements that we define in the paper. For each of the Jewelement, we analyze its physical affordances and how those physical affordances could be connected to interactions. So let's right now look at the analysis for 2 of the Jewelements. So a chain is a very interesting Jewelement due to its flexible and slinky character, due to which it creates the possibility for manipulation gestures. The disc and tags are basically plates which provide surface for touch interaction. And their specific shape and size decides the touch interaction that they can support. The second important part of our taxonomy of jewelry design is the different body locations. And like in case of Jewelements, we analyzed each body location and thought of interactions that made sense with respect to that location. So let's consider our analysis for a necklace and a bangle, for which we use the definition of jewelry as defined by O.P. Untitled in his book. So O.P. Untitled defined the necklace to have a frontal form. It lies back straight on the body and can be accessible from one side, which makes it ideal for touch interaction. Similarly, bangles have a cylindrical form. Once they are worn on the arm, they lie loosely on the wrist, which allows us to move them over the wrist, hence a physical manipulation interaction. So once we had the taxonomy, once we had the Jewelements and the body locations in place, we started to analyze the artifacts that we had bought from the market and started to design interactions for them. And they serve as research artifacts as defined by Zimmerman, again in the definition of RTD. They can act as examples for anyone who wishes to design interactions with their specific artifacts. So these are some of the artifacts that we designed for. And for each of them, we broke them down into their constituent Jewelements and also analyzed the body location to come up with interactions. Again, let's do that analysis for 2 of the artifacts. So the figure shows a grape-shaped necklace, which consists of 6 circular rings and this U-shaped plate. And these are the interactions that we designed for it. And it is visible that the base of this interaction lies in the disc and tag, or the Jewelements that are part of it. And also the necklace form factor, which being frontal, allows touch interaction. So as it is visible in this table, the 3 gestures are enabled by the shape of the element, the shape of the necklace, and the presence of plates, which are tags. Here it is important to consider the concept of input dimensionality, which allows us to connect any gesture with a potential application. This concept was popularized by Ken Hinckley in his 2012 paper. A mouse has a dimensionality of 2D because it can be used to control two parameters like the x and y coordinate of your pointer on the screen. A knob has a dimensionality of 1D because it can be used to control one parameter like the volume of your smartphone. And finally, a button cannot be used to control any parameter, but it records a state change when you press it multiple times. So it has a dimensionality of event as defined by Dr. Ken. So bringing this concept to our gestures, we can say what the dimensionality would be for the three gestures that we defined for the grape-shaped necklace. Going to the other artifact, which is the pendant necklace. It has a chain that is wore around the neck and has a pendant attached onto the chain. And these are, again, the interactions that we designed for it. So again, the Jewelements that were part of this artifact, i.e. the chain and the chain pendant arrangement, was responsible for the interactions or contributed to the interactions. And also, obviously, the shape of the necklace, shape of the neck where the necklace is worn. And again, we can look at the dimensionality, which would be 1D, 1D, and 1D plus 1D in this case. The 1D plus 1D case is interesting because the third gesture can be used to control two independent properties at once. So this brings us to the last part of our process, which is implementing this sensing for sensing these gestures. To implement the sensing for the grape-shaped necklace, we use capacitive sensing techniques that are very popular in Kai community, specifically in the system design, system engineering field. So one thing interesting is that to make these metal rings as separate electrodes, we had to replace the metal jump rings that they came with and tie them back with thread so that we could use them as separate electrodes for capacitive sensing. Coming to the pendant necklace, we use a resistive potentiometer network. So initially, we added small external resistances on the chain of the pendant necklace, but that made the artifact very messy and made the things complicated for us. So we adopted a very interesting approach. We took a conductive rubber cord, put the pendant on it, and wore it as a necklace. So the conductive rubber cord acted as a resistive thread, and when the pendant was moved over it, the relative resistance of the two parts of the cord changed, and we could observe it using a potentiometer. So now let's consider a speculative application, which shows the spirit of designing interactions with jewelry. So here we consider that the way a user chooses to wear the jewelry can become a choice that she makes for her in the morning. So for this specific interaction, we used a Jewelement called a multi-strand clasp, which has multiple jump rings where the chain can be put into. So if it's a working day, the user can choose to put the chain into the one jump ring. And if it's it is printed actually working day here. But if it's a holiday, then the chain can be put into a different jump ring, which is 3 in this case. So this information can be passed to the phone, and the phone would react correspondingly. Like, for example, if it's a working day, the phone would send the usual notification to the person. If it's not a working day, if it's a holiday, then the person won't get any notifications from the phone. So, and she can enjoy her picnic. So now to conclude this talk, this is the overall knowledge contribution that we make in this paper. The taxonomy of jewelry design that we contribute can fill in the gaps in the Kai community associated with the jewelry styles, and also how those jewelry styles can be connected to interactions. Also, our research artifacts, where we talk about the interactions as well as how those interactions can be implemented, can serve as design exemplars for anyone who wishes to design such interactions for their specific artifacts. Also, this table that you see on the right, is a summary of all the artifacts that we considered and the gestures that we developed with them. And it also shows the dimensionality, which can make easy connections to application. So this table can act as a quick reference, again, for the practitioners who are interested in prototyping such interactions with jewelry. Now, coming back to our methodology, this table shows what exactly we borrowed from the 4 different disciplines that we talked about initially. For example, we talked about the sensing techniques that we borrowed from the system engineering domain, or obviously the jewelry design knowledge that we borrowed from jewelry design and literature. So with this, I conclude my talk. I thank my co-authors, and I thank you for attending this talk. I also thank Google India for sponsoring our travel to this conference, and I'm open to questions now.
We have around 3 minutes for questions.
Thank you. Hi, Jillian Hayes from UC Irvine. So first of all, thank you for this. The designs you made were absolutely beautiful, and I want to wear them. But I also am aware, if we think about audio interfaces and all of the challenges that we've had over the years in knowing when you're actually talking to Alexa versus when you're talking to your friend Alexis and so on, I fidget with my jewelry constantly. How do you deal with people like me?
So that's definitely a problem. To separate the noise from the actual signal, or to separate the actual input from the random touches to the jewelry. But how we see it is that this is a very initial exploration of how to explore interactions with jewelry, and these kind of functional constraints can come in when someone someone chooses to implement jewelry for a particular artifact.
So I also have one question. I really like your taxonomy about the jewelry design space. But I'm wondering how can you extend this taxonomy? So one thing from the engineering perspective, I can see we can also do the 3D tracking for all the jewelry objects. See, I have a ring, I can rotate it, I can move it in 3D space. And but I was trying to fit my this interaction into your taxonomy. I didn't find a way to do it. Do you have any idea on that? The
moving the ring example?
Yes.
So how we considered ring was it is a cylindrical jewel that was worn on the finger.
Yes.
So yes, you can move it and you can rotate it, and those things we have included in our taxonomy. But if you consider removing it and rotating it,
yes,
in air, since it's a jewelry element, we consider that it is on the body location, which it is meant for while you interact with it.
Okay. Yeah.